So good morning, everybody, and welcome to this VOJEXT webinar focused on collaborative robot pilots in construction and automotive. We will start the webinar. My name is Louisa Bouzouba. I am EU Project Manager at EMC2 Cluster in France, and I will be just introducing the program today before giving the floor to my colleagues from VOJEXT projects. So just to let you know that this is a webinar that is organized as part of SERI. We have been organizing this webinar in order to present the different use cases that we have in the project. And you can find the previous session on our YouTube channel. Today, we will focus on presenting two of the use case. The first one will be the one developed in Acciona, so focusing on construction sectors. And then we will have the use case developed in Mercedes Benz Turkey on automotive sector. So just before to start, to give you some housekeeping rules, we will ask you to turn off your camera and stay muted during this webinar. Please note that the session will be recorded. So if you don't wish to be identified, please edit your details to hide your name. And at the end, we have planned a time for interaction and question and answers. So don't hesitate to place your question in the chat during the webinar. We will be pleased to answer at the end. Well, without further delay, I will give the floor to Xenia, our project coordinator, to introduce the project and explain a bit more the content of today's webinar. Xenia, the floor is yours.
Thank you, Luisa. Hello, everybody. Thank you very much for sharing and being with us today. We would, as Luisa commented, we would like to share the result of the last two use cases that we are integrating. It's been a hard but very, very, very nice way to get through the project. We are almost finishing. So we would like to share with you the last results of our projects. And those are our two big companies that are in the project with us. VOJEXT as such, as you have seen maybe in the also is the a European Union funded project. It was funded during H2020 framework. And what we aim to do is value of joint experimentation for digital technologies in manufacturing and construction sectors. We focus in mobile robotic systems, but actually aiming to go to cobots, mobile cobots as such. So actually, we would like and we aim to have new ways of automation. Either they are semi or fully automatic solutions for the companies and link it with the CPS systems. That means with all the internet sensors that are around the machines and the production system that really supports the production of the different pieces, okay, on the different organizations that we have. But together with this, okay, we really focus in human-robot collaborative environments. That means our mobile cobots, okay, support flexible configuration and repurpose the manufacturing system. We would like to provide some scalability and flexibility in the means of production as such. Sometimes the focus is not that much in efficiency, but also to allow the robot and the humans work together and actually focus in other areas like it could be quality, as you will see in the following use cases. Our idea has been to provide a favorable environment for these companies to actually experiment with these open technologies as such. So next one, Luisa, please. Thank you. So how we're reaching our objective? For reaching our objective, okay, we are 19 partners, 19 organizations from 11 countries in Europe working together. bringing different technologies from the robotic ones to software ones, vision and 3D reconstruction to really support this connection with the sensors around the production systems and actually get the integration of the robot in the air production system as such. From these companies, we have worked together. We first have done of the environments of the productions, and we are working together as a team, as you can see, in the different floor shops, and actually support how the robot can be integrated in the best manner for them. Next one, please. So the way we're validating all the technology we're producing from the robot to the software through the visual components for the different companies and organizations that are facilitating the demonstrators is to have these 5 companies as our use cases. So we have 5 of our organization of the consortiums are our functional use cases, and we're working in their shop floor in the different areas. So we have one company from plastics in Hungary. Actually, what they produce is polyurethane among some of the other products, but actually they have brought out the production of pillows and how to handle pillows. And we have gone through challenges from this kind of a sticky material and to process and to handle it, and actually to support how not only human errors, okay, can be overcome, but also how robots can collaborate with humans, because one of the issues that they have is lack of personnel supporting their production. The other use case we have implemented is in the electronics domain, and it has been led by OSAI in Italy. And actually, they're an automation company. And what we are doing is how to improve, okay, their current concept of robotics, going from fixed robotics to mobile robotics in collaborative environments, and how to apply it in electronics. They have different challenges, not only because their products are very small, but the idea of them is to have also flexible means of production and see how the robot can be used in one or several machines as such. The other use case has been the craft one in Italy. For this, it has been to be used in very small companies that they produce tiles. Actually, it's a very, very artisan company, and their challenge is how to integrate robots in the area of production as such, maintaining the creativity of the designers of the tiles to maintain the craft and art, and actually how to support the next sustainability of their companies as their third generation mostly are not getting to the sustainability to the company, because actually the lack of human resources is one of the big issues for them. And then the last 2 cases are the ones we are presented today. We're finalizing the integration at Mercedes Benz in Turkey, and this is, as you might know, a big automotive company, and actually the idea is to have the collaborative environment linked with their IoT system and CPS system, and actually supporting improvement of quality driven by data, as a big company that they are going data driven for having better quality in their products. The other company is Acciona, is based in Spain. Is one of the largest construction companies, and actually the idea is to integrate robots to support their human resources when they are at the construction level. Please. So with this, okay, we would like to give the floor to the Acciona use case, and actually we will share with you the results of this use case, and following we will have the results from Mercedes-Benz. Thank you very much.
Thank you, Xenia. So we are from Acciona. We are responsible, as Xenia said, for the use case of the construction. So it's a multifunctional robot collaboration with human operator in a construction wall finishing. Before we dive in with our demonstration, we would like to present a little bit briefly what is Acciona. So we are a large construction company, originally from Spain, but nowadays with a worldwide presence in more than 40 countries, almost 60,000 employees, also spread around 5 continents with over 100 years of history. And besides the construction business, Acciona also has an extensive portfolio of innovative solutions in energy, infrastructure, water, cities, social, real estate, and also financial. And inside this business of Acciona, we also have this building technological center. That's actually precisely where we are located. The mission of this innovative center is to bring innovation, value engineering, and digital transformation to our projects to improve their performance, productivity, and sustainability. And for that, we have several working groups. Ours precisely is the sustainable building group, but we also have groups dedicated to roads, tunnels, and railways, maritime works and structures, concrete, new materials, and digital innovation. So we are a group of more than 70 employees. We have participated in over 30 finance projects, but we also have our internal research projects. For that, we have 14 labs, 6 test cells. One of them is the one we used for our first round of demonstration for VOJEXT, and also a workshop. In our sustainable building group, we have many research lines of investigation, and for coping with the main challenges we face today for sustainability and all its facets. And for example, we were working with the topics of digital twins, digitalizing process in the construction site, bringing on-site renewable energy for the construction works, and also bringing this collaboration and automatization with the robots. That's where we have the VOJEXT project.
Thank you, Carla. I'm Jorge Escribano, also from Acciona. Well, I'm going to explain what we are doing in the internal line, in the internal project of automatization of construction works. Our objective in this sense is to try to introduce the industrialization process in the construction works in order to take advantage of the new robotic and digital technologies for this kind of works. The strategy we are following is to select commercial items to evaluate its functioning in real conditions in our construction works, and to adopt this technology if they demonstrate their viability to have the service of this technology in the works. Okay, but also we participate in research and project development, like VOJEXT project, because it's very aligned with this internal project. In this regard, we have done a technology selection between all these commercial options, but we also have the option of try to develop good solutions from this kind of funded project like VOJEXT. We have also participated in other projects related to robotics for construction, like Festus, a system to install facades, and also VOJEXT, of course, and Human Tech with several functionalities. And the last one is one of the commercial items we are testing in our real construction sites. Well, what are the main, next please? What are the main interests of Acciona in this project, and specifically in the use case for? First of all, we think that the project takes we can take advantage through the project VOJEXT to introduce this robotic and digital technology in the works. In this way, we can optimize the quality, the cost, and the timing of these tasks, and introduce the industrial production concept in a difficult environment like a construction site. With this, we also reduce risks and improve safety and health of the human workers, and combats a big problem with the lack of skilled workers for certain tasks. In this way, we also think that the VOJEXT appeals to the new generation of workers who like to work with these advanced technologies. Next, please. Yes. Well, according with all this, our main rule in the project is to prepare the demonstration in a simulation and simulated environment, simulating the construction works conditions. Okay, in this regard, the construction works use case consists basically in finish to carry out the finishing of plasterboard walls. Okay, in this case, we have several options of quality. We have chosen the better that which has the better quality. The Q4 quality. The entire wall, drywall surface must be fully covered with this quality. We have also some challenges like the aggressive environment of a construction site, variability of working surface and workflows, identification of the characteristics of the walls, functionality of different tools used, interaction between the Cobot and the human workers, of course, safety of the human workers, the training of these people, and the performance and costs associated to the Cobot. Well, to do this, the workflow that will be followed in this use case consists of 3 steps. The first one is the taping of the joint between the plasterboard sheets. The second one, the spraying of the finishing paste on the wall, and the sanding of the plastered surface. Okay, with these 3 tools: the taping tool, the spraying tool, and the sanding tool. Well, to carry out this use case, we have prepared 2 scenarios. The first one in Madrid, with the reproduction of a real construction environment with the construction of 2 walls with plasterboard sheets in one of our test field close to Madrid. Okay. Here we did the first demo phase of the use case. That was a first confrontation of the robot with a simulated real environment. Well, the second demonstration was carried out by Robotnik in Valencia, and in this demonstration we have done the second phase of this development, consisting of the refinement of the Cobot functionalities for the use case 4. This activity was finished now in May of this year. In this case, with Robotnik didn't use a test cell, but they reproduce two walls structures, simulating a corner in their facilities. Okay. Well, now we will see the demonstration, some videos and so on. Thank you.
Thank you, Jorge. So now we will indeed see the demonstration with the teams that are currently on site. So I will stop sharing my screen and we will welcome the team. The floor is yours.
Hello, welcome everybody to this demonstration of use case 4 in VOJEXT. In this case, we are going to show you the taping case. First, the robot right now is waiting for the validation of the tool changing. As we have different tools and different operations, we need a process in order to change the tool correctly and safe for the worker. Okay, once the tool installed, you have to validate the process. And now the robot will move the arm to a safe position to start moving. The arm to the home position. It will move to the in front of the wall as we detect with the camera, with the perception module, the joints that we have in the wall. It will localize in the map that we previously done and move in front of the joint. And then it will start to move the arm again to the start position of the taping. Thanks to the lasers that the robot has installed, it knows where it is inside the map and will move to the position. Good. Thanks to the lasers that the robot has installed, it's secure to be moving close to the robot, so I can attach correctly the cover that it has. And now the arm will start moving to the joint position where it will start taping. Before the robot starts the movement of the arm, it's aligning to the wall to be correctly oriented. And now I have to start the process by checking that the tape is in the correct position, tool, and prepare everything to start. Right now I can see that the tape is fine, it's prepared. So I can validate the position and the robot will start moving. First, the arm approaches to the wall, and with the force detection that it has, we detect that the arm is touching the wall and start the movement of taping. It will go up following the joint that we detected previously with the perception module. Once the arm reaches to the middle position, it will stretch the tape, as you will see soon. And then a cutter will be used to cut the tape. Now, as before, the arm is moving to the wall, and once the force sensor detects that it's touching the wall, it stops and cut the tape. Now we will finish the taping and moving slowly to attach it correctly. Once the tape is correctly pasted in the wall, the arm will move to the previous position, to a home position where the movement of the base is safely for the operator, and it will move to the next joint. As before, the robot is aligning to the wall. So as you have seen, this is the process of the robot taping the, as you can see, this is the process of the robot taping the wall. It will continue moving to the rest of the other joints. And now we will move to the next use case, show you the next robot.
Thank you very much. So indeed, this was in the demonstration of our first use case. We will now move to the second part of the webinar that is dedicated to the use case developed in Mercedes Benz Turkey. So you can see the technical team now because they are actually on site, and I will welcome Okan and Xenia from Mercedes Turkey side.
Hello, Lucia.
Yes, Xenia.
Yes, give us a minute. Bilal is also connected from Mercedes-Benz side, okay? And they're going to be presenting Mercedes in a minute. Let us just reconnect for a minute, and they put the cameras, and we'll be in a minute presenting.
Yes, in any case, a short break was planned. So for the audience, if you want to grab a coffee, just a minute or two, and we will move to the next use case. So for the audience, we were silenced because we were having a break between the two use case presentation. As you can see today, we focus on a use case on construction presented by Acciona in the first part of the webinar. And we will move now to the second use case presented by Mercedes Benz Turkey. I think we will start soon. I don't know, Okan.
Yes, I'm on the line. I can start.
Okay. So we will listen to you, Okan, to present indeed your use case and your company before the demonstration of your use case.
Let me share my screen just a second. And hello to all again. I guess you can
Yeah,
get to page, right? Yeah.
it's not in full presentation mode. Now it's good.
Okay. Hello all. So this is Okan. Together we are two colleagues who are the persons in charge of EU projects. So my colleague is Bilal. He will briefly introduce himself as well. So my main scope is mechanical simulations and the general coordination of the projects. Today we are going to present to you what kind of scope we had in the beginning of VOJEXT, what kind of KPIs we had, and then at the moment what we have received as the output. So let's share the informations with you. But beforehand, I would like to briefly introduce most of you, all of you probably know the meaning and the competence of Mercedes Benz. We are one subsidiary of Mercedes Benz in Turkey. Trucks and buses are being produced in Turkey, not just being produced, but also being developed geometrically, mechanically, and physically. All those tasks are being managed, handled from Turkish engineers. This is somehow the workflow. So we have at the moment two R&D centers, one physical test facility, and one IT hub. All those hubs and offices, not just supporting the Turkish ecosystem, but also globally, they have been supporting their engineering expertises. We are dominant in bus sector. We have many bus portfolio, as well as for the truck sector, we are also so dominant in the sector and in the market. Mainly two truck types, vehicle types are being developed and produced. Construction trucks and tow trucks, you can easily see anywhere else in your country or other countries. Let's mention something about the development tasks for bus and for truck. All components, exterior, interior, load carrying, cosmetic, all those parts from zero level to the final level, controlled, managed, designed, assigned, whatever. They all are being designed in Turkey. And also one strong property of us, what we generally put in such kind of EU projects, the testing. So if anyone else, institutes, suppliers, technology providers, if they would have an idea, so we can easily embed it into the vehicles, onto the vehicles, and we can let it to be tested on the road under exact road conditions, so that all those technologies can see their qualities. Here you can see those test ways all around Turkey. On the right side, you can see, just let me open the pointer. Yeah, all around Turkey and in Europe, in Germany, we have test ways, roads, let's say, so we can collect data and we can comment on the results. Yes, these are somehow the brief information about the company. Let's switch into the VOJEXT. So the main problem was in the beginning, the anomalies and unexpected damages in the plastic components, fiber reinforced or non-fiber reinforced plastic components. So we thought that on that time, what to do, how to fix those problems. So we need to dive into the mold, and we need to examine the mold. We need to get something out as the experience, and we need to use it in digital twin model, let's say. Here you can see some problem statements: incomplete filling, weld lines, high-speed injection, therefore the air traps for the fiber reinforced plastics, tensor of the angle of the fibers, fiber orientations, fiber distribution, if there is any breakage, so we need to take it in account, so on. Yes, on this page you can see the demo part. We have selected the fender. Imagine that trucks has many tires, axles, and those tires are surrounded by fender on it. Those fenders are connected to the chassis with a steel component. So this part is at the moment originally made of steel connection. But within the scope of VOJEXT, so our main aim is to converge it into the plastics, fiber reinforced plastics. So one by one, we have been collecting the production data to understand where the anomaly happens. Yes, some results. For example, weld line, as I mentioned, on different locations of the part. So this part is a bit complex, as you can see. There are many ribs on it, many radiuses, and inside we have friction welding or direct fixation in the mold of this part to that part. Those weld lines not should but must be detected accurately in order to avoid unexpected brittle damages. So these all are detected by using AI-based software. One algorithm was developed, and then the collected data was processed by using this algorithm, and then this data was transferred, moved into the digital twin model. I will show you later on. Yes, this is also one very crucial, essential output fiber tensors. So the red colors represent the high ratio of the fibers, whereas the yellow, green, and blue ones show the low density of the fibers. So each location has its own mechanical property, so that we cannot use just one mechanical property list. So we cannot look to this part and to this material. This is isotropic, this is anisotropic. So we need to give this anisotropical data. Yes, some other weld line locations. Weld line means the gap. So this gap should be filled, or nevertheless, we need to put it into the model, then we can see the accurate stress and deformation results. Yeah. So this is the conventional method on the left side. With the open call winner, with one of our current suppliers, VMansis. So we have done this study. They have supported us. Normally, isotropic and very basic TDS technical data sheet is used. But now our proposal is to use this phenomena instead of this one. So what we will do and what we are doing now, we will get those mold data, not just from the virtual, but also from the sensors, what we put in the mold. So we will get the data, we will examine it by using AI, and we will put it into the structural virtual twin model. For some mistakes, some errors, some failures can be detected through this new method, novel method. Here is one example. So here you can see this is the cut section of the demo part. Those areas are air void and weld line connections. So the system, the algorithm, and the program, the tool converts the isotropic material into anisotropic materials. And here you can see for the tensile. So we generally got 21 MPa is the highest stress. Now with the VOJEXT solution, we can get 26 MPa. So the yield limit is 27 MPa. So if we would not use molding result and the VOJEXT output, open call winners solution, let's say, so then we generally say, okay, this is okay. This part will not have any damage. But after putting this effect, this contribution, then it is around 0.9. So it is about to exceed the limit. So this is a very essential contribution to us. Currently, we feel ourselves more insured and more in conservative zone to catch the damages and not to have the damages on the customer, as well as on the bending, not just tensile, but also bendings. We have the difference, what we need to find out previously. So this is called somehow, we can call it predictive maintenance. We are now predicting the damages and we maintain it. This is the integration of the system. We have our sensor collected data. We find out the anomalies in the micromechanical structure. So we put it into the diagram, stress strain diagram or FX diagram. Then we put it into the finite element software. At the end, you will get the results. Yes, this is from our side all. Thank you for your attention. If you have any question, we can gladly answer it. Bilal, if you wish, you can also with a couple of sentences introduce yourself. I guess Bilal has some audio problems. Anyway, so please contact us if you have any question. Many thanks.
Thank you, Okan. We will start to put and show the demonstration from Mercedes Benz. This is a demonstration that is parallel done at Robert Nick in Valencia and Turkey Mercedes Benz.
Welcome everybody again. We are in the second demonstration now in use case 3. And moment we are going to start the system First, the robot will pick a piece of the injection machine. Now it's waiting for my validation to start. And the process will start. As you can see, the mock-up of the injection machine start working, hitting the piece. Once it's finished, the door will open again and the robot will start moving. Now I have to announce that the machine has stopped working and the robot can start working. Now the robot is localized inside the map that we previously done, and thanks to the laser, is navigating in the map, moving in front of the machine, and aligning to a correct position. Thanks to the perception model that we have, the piece is detected in the machine, and the robot arm will start moving to the position in front of it. Once the arm is positioned in front of the piece, it will approach to it. And thanks to the force sensor that it has, it will pick the piece with the pneumatic system that the gripper has. As you can see, the robot has the piece, and now we'll start moving to the table of inspection, where it will be placed. I will check the results of the injection. Now the robot will move again to the initial position, waiting my confirmation. So now I place the piece in the correct box as it's an okay piece. And now is waiting my validation of the piece, the results of the piece. Now the process starts again. The operator has to pick the pieces. I can see that the piece is okay. I will have to validate the piece to the robot. And continue working in the process. This will be done repeatedly. Then the robot will start again for the process of validation. So I pick the piece, validate it, and send the results to the robot. And for the last time, I will pick the piece, validate it, share with the robot the results of the injection, and this time the robot will pick the piece. So again, the door is closing, starting the injection process. After the process has finished, I validate to the robot, so we can start move to the machine. As before, the robot is localized in the map, moving, navigating with the lasers that it has, and aligning to the machine. At this point, the camera and the perception module is detecting the piece and sending the robot the coordinates where it is. So the arm moves in front of the machine, of the piece. Approaches to it, and once it detects the gripper is touching the piece, the pneumatic system activates to pick the piece and return the arm to a home position where it's safe to for the operator and for the robot to move. It will place the piece in the table where I will pick it to inspect. In the meantime, the robot will come back to the home position where it will be waiting for my validation. So as you can see, this is the process, the workflow. The robot combines with the operator to do the visual inspection, and pick the pieces from the injection machine. Thank you for being here and listening to us, and see our demonstration.
Hello, Lisa, here from the shop floor. We are ready with the demonstration, and also from the lab, also we are ready from the demonstration.
So Xenia, maybe, so we saw now the different demonstration and the different process in the two use case. I don't know if you want to add some
Yeah.
elements before concluding. Just to remind that the audience, if you have some questions, don't hesitate to add them in the chat. Currently, I don't see. But Xenia, maybe if you want to add some elements regarding the two demonstrations that we saw.
Sure, there is a little bit of noise here, so apologies. We are at the shop floor, just at the production installations. So, but yes, we would like to say that we are very happy with the demonstration. In both cases, had been successful. The idea behind the construction environment, it was to get not only the taping, that is what we saw today, but also for the painting, okay? And also we are able to manage, okay, the robot in the different environments. We were able to start in Madrid, in Acciona, and to finish in the lab to extend the use case as such. So actually the results had been successful in this case. And actually with Mercedes Benz, as you said, we were able to connect remotely the machine at production stage here in Turkey, while we were managing the robot in Valencia at the lab station with a big mock-up and simulation that we have done. For them, the quality inspection is very important, because what they have done is to manage their clients, okay, with robotic systems and ensure a data-driven quality approach at their installation, which for them as a company is also very important. So actually, I think those are the two main conclusions from the use cases. And with these demonstrations, we finish all the demonstration of the 5 use cases at the VOJEXT project, and happily ending the project in a month from now, or less.
Thank you, Xenia, for these concluding words. Indeed, as I was saying, this is part of a webinar series that we have been organizing in order to present the different use cases. So if you are interested to know more, please don't hesitate to look at the different channels of the project. We have information on the project website and different video in the YouTube channel. I would like personally to thank all the teams, and as you can see, we are a lot involved in this project, and thank you for this demonstration, setting up everything in order to present you the result of our projects. So yeah, hi everybody, and since I don't see a question. Yeah, the other team. I don't see question on the chat, so I think we can conclude here, unless Okan and Jose, you want to add something. If no, then we close here. Thank you for your participation, and don't hesitate to look on the further details on the project website.
Thanks to everyone, and thanks to the audience.
Goodbye.